Good day, folks. This is the review for the test number 4, and this will be your last test. And after this, there it will be a final exam. Hooray! So you made it. All right. So let's start with the review of the chapter of the test 4, shall I say? First matrix is given to me: 7, 3, 2, 1. 2, 5 minus 2, 1, 8. This is a 3 by 3 matrix. Another matrix given to me is 2, 2, 1, and here 2, 1, 3, and 1, 2, oops, 1, 2, 1. And we wanted to multiply these matrices. And how can I multiply these two matrices? So first of all, 7 times, you're going to go in this direction, and then from here you're going to go in the downward direction. So 7 times 2 plus 1 times 2 plus minus 2 times 1. And this will be your first term of the new matrix. And then this term will be, so again you will use these terms, and then multiply it with these terms. So 7 times 2, this 2, and then this 1 times plus 1 times this 1, and then plus 5 times 2. 5 times, I don't know why I end up thinking about 5. My apologies. It should be minus 2. Minus 2 times 2. That's how I should have written it. I got distracted. So let's look into the third term. Again, these three terms, top three terms, multiply by these three terms. So it will be 7 times 1 plus 1 times 3 multiply by minus 2 times 1. So these are the terms. And then the next is we're going to use this row, the second row, and multiply it by the first column. So that will be 3 times 2 plus 2 times 2 plus 1 times 1. And then same thing I'm going to apply a second time around. 3 times 2 plus 2 times 1. So this one and this one I'm multiplying right now, plus 1 times 2. And then the third one, again, I will change the color, this and this. So 3 times 1 plus 2 times, whoops, plus 2 times 3 plus 1 times 1. And then the third one is 2 times 2, this and this, 2 times 2 plus 5 times 2 plus 8 times 1. And then 2 times this same terms multiply by this, 2 times 2 plus 5 times, whoops, 2 times 2 plus 5, I don't know why I cannot write it, plus, whoops, it's not allowing me, plus 5 times 1 and plus 8 times 2. And then the third term, that is 2 times, same again, this and this, 2 times 1 plus 5 times 3 plus 8 times 1. Again, it's the pen stopped working. 5 times 3 plus 8 times, whoops, 8 times 1. And now when I'm going to simplify them, that's going to be 14. This will be 1, then 8, then 11, 10, 10, 22, 25, and 25. That will be your final answer. That's how you're gonna do this question. Now let's look into the next one. Add the following. Add the following. And now the first matrix is 7, 3, 2, 1, 2, 5 minus 2, I guess. Okay, I'm using minus 2 here. 1, 8, and then plus 2, 2, 1, 2, 1, 2, 1, 3, 1. Can I add these matrix? So when we are adding the matrix, this is very easy. So first term of the matrix with the first term of the other matrix, second term with the second term, third with the third. So pretty much straightforward. So this will be 9, 3 minus 1. 534,379. That will be the answer for at the following. Let's look into the third question now. Find the determinant of the given matrix. So that will be 7, 1 minus 2, 3, 2, 1, 2, 5, 8. That's the matrix given to me. So 7 multiplied by 2 times 8. So first term, and then multiply these two and this two and subtract them. Minus 5 times 1, then minus 1 multiply by well, this will be 3 times 8. So 3 times 8 minus 2 times 1 and minus 2 and 3 times 5 and minus 2 times 2 minus 2 times 2. All right, and then it will be 7, 16 minus 5, and that will be, I'm adding an extra bracket here, don't know, minus 1, 24 minus 2, and minus 2, 15 minus 4. And then 7 times 11 minus 1 times 22 minus 2 times 11, 77 minus 22 minus 22, that is 33 is the answer for this question. All right, let's look into the next one. So we wanted to find the XYZ value from these equations. There are three equations given to me by using the Gauss, no, not the Gauss-Jordan method, Cramer's rule, I guess, yeah. Using the Cramer's rule, we're gonna find the XYZ value equal to minus 2 and then 2x minus 3y minus 6z equal to 3. Now when first thing I'm going to do is put it in the matrix form. 7, 1, 2, 4 minus 2 minus 4, 2, this is x, minus 3 minus 6, and then x, y, z, and down here this will be 7 minus 2 minus 2. All right, now I'm gonna try and first of all find the determinant of this given matrix. 7 minus 2 times minus 2 times minus 6, and then minus of minus 4 times minus 3. And then the second will be minus 1, then 4 times minus 6 minus 2 times minus 4. All right, and then the third will be plus 2, this one, and then the terms I'm going to take are these 4. 4 minus 3, 4 times minus 3 shall I write? 4 times minus 3, and then minus 2 times minus 2. 2 times minus 2. Oops, times minus 2. And now when I'm going to start simplifying it, this is going to give me 7. This will be plus 12. Oops, plus 12 minus 12. And then minus 1, minus 24, minus 8. And then minus or plus 2, minus 12. This is minus 12 minus 4. That's what I'm going to get from here. Now I'm gonna say 7 times this will be 0 minus 1, this will be minus 16, and plus 2 minus 12 plus 4, and minus 16 minus 1 plus 2 times minus 8, and then 16 minus 16, that is 0. So we got the determinant as 0 in this. So now I'm gonna just try and find out the one more determinant by replacing the terms, the first column with these values, and see what value do I get. I'm going to replace the first column with these values, 7 minus 2 and my 7 minus 2 and minus, well, this is 3. I don't know why I end up writing here minus 2. So this is 3 down here. So 7 minus 2 and 3 in the first column, and these terms will remain the same. So that is 1 minus 2 minus 3, 2 minus 4 and minus 6. That's what I've written it. So see, these terms are same. And now I want to find the determinant of this. So 7 times minus 2 times minus 6 times minus 6, and then minus of minus 4 times minus 3 and minus 1. Then these terms I'm going to take minus 2 times minus 6 minus 4 times 3, and then plus 2 minus 2 times minus 3 minus 2 times minus 3. That's what I'm gonna write. And 7 times, oops, 7 times 0 minus 1, 12 plus 12 minus 2 times 6 plus 6. So minus 1 times 24 plus 2 times 12, and that's going to be minus 24 plus 24, that is 0. So 0 over 0, no solution, and you can leave the remaining. But if there was some value of this determinant, then you would have solved for the second column also, and after that you would have solved for the third column by dividing same way, by dividing the values, numerator and denominator. This denominator will be the determinant of the initial matrix which we got, this matrix. If there was a value, we would have divided the new matrix by the uh, initial determinant which we got. That would have given x, y, and z values. So for y, I'll change the middle values. For z, I'll change these values, and then whatever value I'm going to get, divided by the determinant value. That's how we're gonna solve it. And if you wanted to want more detail, please make sure you watch the Cramer's rule video, which I've already posted. All right, now to the next one. Just wanted to give you a heads up. For the second one, when you're trying to, if you wanted to solve for y, you're gonna get the value as 312 divided by 0. For z, you're gonna get minus 156 divided by 0. So again, there is no solution for this one. All right, now let's look into the next question for our given topic. So I was just checking out this question is huge. So 1, 2 minus 1 and 3, 5 minus 1 minus 2 minus 1 minus 2. And I wanted to find the inverse of this by using the Gaussian method. So first of all, I'll multiply it with identity matrix 1 0 0 0 1 0 0 0 1. And now I'm going to start applying the operation. So I'm going to apply the operation R2 on the row 2. The idea is to convert it into an identity matrix, and whatever operations I'm applying on this one, by applying those same operations I must apply on this one, and whatever values I'm going to get from this matrix, that will be the inverse matrix. All right, so R2, first of all, on row 2, I will apply, that is R2 minus 3R1. So let's apply those operations. So that's 1, 2 minus 1. First initial row will remain same. This will become 0. And on with that also, I will apply on R3 also. On R3, I will apply R3 plus 2R1. Always use R1 to convert this 0 and this 0. Okay, so 0 0 here, this will be 5 minus, if I apply this operation, R2 minus 3R1, 3R1. So this is 5 minus 3 times, I'll just show you, 3 times 2 is 6. So 5 minus 6, and down here minus 1, minus 3, because 1 times 3 is minus 3, and this was already minus 1. Subtract, this is a subtract sign, minus 3 from there. And then for the third one, I'm going to apply this operation because this is on R3. So this first term will become 0 when you're going to multiply R3 minus 2. See, minus 2 minus, so plus, actually this one, plus 2 times 1. So 2 plus 2, minus 2 plus 2, that is 0. That's how I got this 0. So now for the second term, if R3, which is minus 1 plus 2R1, twice of this value, that will be plus 4. And then down here it is minus 2 plus 2 times minus 1. And then same operation I must apply on the second one also, 1 0 0, this will be minus 3, and 1 0, this will be 2 0 1. Just applying the same operations, these two operations on R2 and R3. And I'm going to compile the results from here. This will be 1 2 minus 1, 0 minus 1 2, and 0 3 minus 4, and then here 1 0 0 minus 3 1 0 2 0 1. All right, now the next operation I'm going to apply, that is on R3, that is R3 plus 3R1. Now objective is to make this one as 0, because we've already made first these two as 0. We're going to follow a pattern here. Okay, so first of all we're going to make these two 0, then I'm going to make this 0, and then I'm going to make some other terms, this one 0. That's how we're going to try and move. Okay, so let's see. So this will be, whoops, I accidentally opened something else. All right, so this will become this one 1 2 minus 1. First row will remain the same, and this is 0 0 and minus 1, because R3 plus 3R1, 3 times R1. I am applying the operation here. Well, not 3R2, I guess. Yeah, this is 3R2, because if I add this one, then it will be some value down here. So this will be, if I 3R2 minus 1, so 3R2, this was 3 plus 3 times minus 1. Yes, this is 3R2. This is R2 value which I'm taking, and this value remains as 2 here, and this is the second term. The third term, I'm gonna erase this and bring it down here so that you're not confused. Minus 1 2, and this will become minus 4 plus 3 times 2, and then same operations I'm going to apply on this one. 1 0 0 minus 3 1 0, and then 2 plus 3 times minus 3. Okay, because this is R3 plus 3 times R2, and then here this will be 3, this will be 1, and now the value will come out to be 1 2 minus 1 0 minus 1 2. Always follow this pattern, the pattern I am following. Just any kind of a question, just keep on following this pattern and you will get the answer. Minus 3 1 0 minus 7 3 1. It's just that there are so many calculations, we tend to make a mistake while doing the calculation, so go slowly while you are doing the calculations. Now the next operation I will apply is on R1, and then will say R1 plus 2R2. So I've made this 0. Now I'm going to try and make this one as 0. So this will be 1 0 0. So R1 plus 2R2. This I will add. So 2 plus 2 times minus 1, which automatically will be 0. Minus 1 0. This will be minus 1 plus 2 times 2, and then this was 2 2, and here I will mark it as 1 plus 2 times minus 3, 0 plus 2 times 1, and 0 here, and then minus 3 1 0 minus 7 3 1. I will recommend you guys to pause the video and do this calculation at your own and see whether you're getting these values or not. And then this is 1 0 3, 0 minus 1 2, 0 0 2, minus 5 2 0, minus 3 1 0, minus 7 3 1, and R3 divided by 2, this value will be 103, 0 minus 1 2, 0 0 1, and what I'm trying to do is I'm trying to make this one as 1 here. So because I wanted to convert everything into an identity matrix, minus 5 2 0, minus 3 1 0, minus 7 over 2, 3 over 2, 1 over 2. All right, now next operation will be R2. On R2 I will apply R2 divided by minus 1, because I wanted to make this one as 1. So 103, 0 1 minus 2. See, this one is now almost getting converted into an identity matrix. 5 2 0, this will become 3 minus 1 because I'm multiplying this second row with the minus 1. So this is an easy step. Minus 7 over 2, 3 over 2, and 1 over 2. This we haven't made much of a change here. All right, so next step I'm going to apply is on R2, that is R2 plus 2R3. So on R2 plus 2R3. So actually the whole goal is to make these terms 0 now, and then later on this term as 0. That's what we are trying to do. So this will be 103, 0 1 minus 2 plus 2 times 1, 0 0 1, and this will be minus 5 2 0, 3 plus minus 7, minus 1 plus 3, 0 plus 1, and then minus 7 over 2, 3 over 2, 1 over 2. And now just gonna simplify this one. 103 0 1 0 0 0 1, and this is as it is minus 5 2 0, and minus 4 2 1, 7 over 2 minus 3 over 2 1 over 2. And then the final step will be R1. On R1 I will apply R1 minus 3R3. That's gonna become now 1 0 0, 0 1 0, 0 0 1. That's your matrix. And now this will be minus 5 minus 3 times, because 3 times are 3. This will be a little complicated calculation. Minus 7 over 2, and this will be 2 minus 3 times 3 over 2, 0 minus 3 times 1 over 2, and this is minus 4 2 1, minus 7 over 2, 3 over 2, 1 over 2. And the final step is this will remain as it is. We're not changing it. I'm just doing the calculation here now. So 11 over 2 minus 5 over 2 minus 3 over 2 minus 4 2 1 minus 7 over 2 3 over 2 1 over 2. This will be my inverse matrix. Hooray! So we finally solved this question. Now the final question is relatively easy. That is on the statistics. So on the statistics, you will be asked basic questions similar to whatever I am doing right now. And yeah, some basic questions on statistics. And the first is, I've been given a data, find the mean, median, mode for the data. So 10 is repeating itself once, 12 is repeating itself 4 times, 14 is repeating itself 5 times, 18 is repeating itself twice, 20 is repeating itself once. So total frequency means the number of times any number is repeating. Total frequency is 13. So I wanted to find the median in this case. Median is the middle value. Median is not the mean. So median means middle value. So I'm going to write them in a simpler format just to understand. 10, 12, 12, 12, 12, because 12 is repeating itself 4 times. Then 14, 14, 14, 14, 14, 1, 2, 3, 4, 5. And then 18 is repeating itself twice, 18, 18, and then 20 is repeating itself once. What is the middle value in these? So total number of values are 13, I can see here. So seventh value is the middle value, 1, 2, 3, 4, 5, 6, 7. So the median is 14. Median is 14. Let's say there were 12 terms. This was not the term. So 6 plus 7, whatever those 6th and 7th value are, you add them. In this case, they came out to be 14 and 14. Let's say they were 14 and 15. So 14 plus 15. Okay, let's say these were 15, 15, 15, 15. So 14 plus 15 divided by 2, 14.5. That's how it's going to become median value. And mode is the term which is repeating highest number of time. Mode is also 14. Mode is not 5.